A function is defined by every element in the domain having one, and only one, image in the codomain. The set of images is called the range. The inverse function can only exist if there is a one-to-one correspondence between the two sets. If a function, f, maps elements of the set A to the set P, then its inverse, f to the -1, maps the elements in set B back to set A. Notice the difference in notation for the function and its inverse. For example, the function f of x takes us to the element y. But we haven't finished yet. The y was a temporary name to help with the rearranging of the equation. Start with the element in set A, called x. Apply the function f to the element x. The image in set B is called f of x. Now apply the function g to the element in set B, called f of x. The image in set C of the element f of x is called g of f of x. Start with the element x in set A. Apply the function, called h of x, to the element x. Its image in set C is called g of f of x. Apply g of x to the element called x first. This x plus 1 is now the new name of the element to be inputted into the next function, f of x. Using the previous example, this 2x minus 3 now becomes the element applied into the function, g. A notable exception to whether or not the order matters is the composition of the inverse function. The graph of the inverse function is a reflection in the line y equals x. If the transformation is inside the brackets, with the x expression, then the translation is along the x-axis. If the transformation is outside the brackets around the x expression, then the translation is along the y-axis. The transformation is inside the brackets with the x, all the x coordinate signs are reversed. This time the transformation is outside the brackets containing the x. All the y coordinate signs are reversed. It may help to think in terms of, how many of these curves do I need to fit into the same x-axis? Think in terms of, only a fraction of the curve will fit into the x-axis. When k is negative, the size of k determines if the transformation is a stretch or compression. The negative sign indicates reflection in the y-axis. When k is negative, the size of k determines if the transformation is a vertical stretch or compression. The negative sign indicates reflection in the x-axis.